continue our introduction to the polarization interference filters. First, the so-called folded slope filters. This filter is designed like this. We have a X polarizer here, and then a pair of wave plates. This has the orientation positive rho, and this has the orientation negative rho. Then we use this as a period, as a unit cell. So we have many period, many unit cells. Positive rho, negative rho, and then finally we have a Y polarizer. Okay. This means that the slow axis along the direction, the orientation of positive rho, which means the slow axis, the angle between the slow axis and the x-axis of the lab is positive rho. And this negative rho, positive, negative, positive, negative, okay. So totally we have M period or M cells. Since one period has two wave plates, so totally we have N wave plates. So to understand what is the function of this design, suppose every wave plate provides the phase retardation gamma, okay? Then we consider the special case that if gamma is equal to pi, we have already explained that suppose we have slow axis along this direction, say rho. Then if we send a light, an X polarized light, then after penetration through this wave plate, the new polarization state becomes this. This is because we can write X polarization as the projection of X into the S-axis is equal to cosine rho. So this is equal to cosine rho times S minus is half pi minus rho. Okay. Minus psi rho f. Okay. Here S hat and F hat denote the unit vector along the slope axis and the fast axis. Okay. So after penetration through this gamma equal to pi wave plate, the half wave plate, then the relative phase between these two components is exponential I pi, which is equal to -1. This means that we change, for example, we keep the first component unaltered and change the sign of the second component. We get the new polarization, I denote it as x prime, is equal to cosine rho times s plus sine rho times f. This means that the new polarization, the original polarization here, new polarization here, the new polarization has the same as projection, okay, cosine rho, but opposite f projection, which means positive sine rho. Okay, so geometrically, this means that this new polarization makes a positive angle rho to the s-axis. So the new orientation makes a 2 rho angle to the x-axis. OK， 就说你现在呢，你一道光偏振光通过这个 wave plate， 如果 wave plate 是所谓的半波片的话，啊，那意思就是说，这两个分量之间的相对项会增加一个派，啊，那前面乘上一些系数，这个都不管它，那些多余的相位都不管它，我们只管相对的相位。相对的相位的话是，它本来相对相位是派嘛，变成2派，或者是变成0，所以呢，从负号就变成正号。那负号变正号的意思，其实就是你本来这个偏振是 S 轴往下转揉，变成 S 轴往上转揉。啊，所以就变成是跟 x 轴夹一个2ρ的角度。So finally, this new polarization, you can see that the new polarization rotate to the we rotate the original polarization to the new polarization. The angle is 2 ρ. 啊，所以这边意思就是说。So when penetration through the X polarizer, the light get angle 0, polarization angle 0, and here the polarization angle becomes 2 ρ. 2 ρ. 好，变成2 ρ。可是下一个。新的 S 轴呢？The new S-axis has the orientation along this direction, minus rho So the angle between this new slow axis and the new polarization is 3 rho. So the new polarization makes the angle rho clockwise to the new slow axis. So the new polarization oriented is along the -4 rho. Okay, so this means that here we have the polarization along the direction -4 rho, and then +6 rho and -8 rho. Okay, and finally, one period give us -4 rho, 2 period give us -8 rho. So suppose we have m periods, we get 4m rho. Okay, we can ignore the positive or negative sign because they are the same polarization. If 4m rho equals half pi, half pi means along the y direction, then the light can penetrate through the y polarizer completely. So this corresponds to total transmission equal to 1. Okay, so this means that since 2m is equal to n, n is equal to 2m. So this means that 2n rho is equal to half pi, or rho equal to rho is equal to pi over 4n. So if rho is equal to pi over 4n and gamma is equal to pi, then we get transmittance equal to 1. 就是说，如果我们所选择的波长使得这个伽马刚好是拍，就这个的厚度跟波长去搭配了啊。The thickness and the wavelength give us the retardation angle equal to pi. If this happens, and suppose we choose rho equal to pi over 4n, then we get transmission equal to 1. 好，所以在这个情况之下，我们会得到穿透率是1的情况。好，那现在我们想要问说，如果我把波长改变，它会怎样？好，因为所谓的 filter 它的意义就是说，我要选出一些特殊的波长。啊，就是我波长变的时候，它就没这个效果啊。那要反差很明显，就只有波长很准的时候，那些波长被抓出来。好，那所以呢，我们现在就要来分析伽马不是拍的情况啊，或者是没有，我们现在还是把 rho 都固定成这个值，但是我们让波长改变，使得伽马有可能不是拍啊。So now we fix rho equal to pi over 4n and change our wavelength to see if we get a gamma close to odd integer times pi, but not equal to odd integer times pi, then what kinds of transmission we will get? 就是我们如果让波长变了一下， 很接近它，但不完全是它的时候，它是一个什么行为？好 ，So first of all, we need to calculate the matrix representation of this mth pieces of wave plates. Okay. So for one wave plate, for one period, we have W rho. Let me denote W rho as this R minus rho times W0 times R rho. This means that this represents the matrix of a wave plate having the orientation rho. Then the wave plate with orientation minus rho can be represented as R rho times W0 times R minus rho. So in one unit cell, we have a pair of wavelength, which is, I may denote it as omega, defined as W minus rho times W rho. Okay, and then finally, the whole structure having m pieces of wave plate or m unit cells, we get the matrix. I denote it as M. The M matrix is equal to the M power of omega. Okay. So once we know how to calculate this matrix, then combined with the matrix representation of polarizers, then we can calculate the transmission of light. Okay? So now we want to study how to calculate the nth power of a matrix. First of all, we need to calculate this omega. You can calculate this result directly by using this definition. Okay, and we have already introduced how to calculate this W0. W0 is this matrix exponential minus I gamma over 2, 0, 0, exponential I gamma over 2. Okay. And R rho is the rotation matrix, cosine rho, sine rho, minus sine rho, cosine rho. And R minus rho is the inverse of R rho, or transpose of R rho, which is equal to cosine rho minus sine rho, sine rho, cosine rho. Okay. So use this matrix formula, you can calculate W rho and W minus rho. You just need some patience to do this. Then we get the omega matrix as A, B, C, D. B. Okay. Here A is given by cosine half gamma minus I cosine 2 rho sine half gamma squared plus sine squared 2 rho times sine squared half gamma. You can check this result by direct calculation. And the B, if you calculate it carefully, then you will find the result is this one, which is different from what you see in the textbook. The difference is this minus sign. And the C is indeed minus B and is equal to sine 4 rho sine squared half gamma. And then finally, in fact, C is minus B star. Star means complex conjugate. And what is D? D, you can remember D like this. You can say that D is A star, which means that you change every I from I to minus I, cosine half gamma, plus I cosine 2 rho sine half gamma squared plus sine squared 2 rho sine squared half gamma. Okay? You can find these 4 elements directly by careful calculation. Then, now we want to see what is the nth power of the matrix omega. To do this, before we do this, I want to say that we have already learned that W rho, the determinant of W rho is equal to 1. Okay, this is because W rho is equal to R minus rho W0 R rho, and the determinant 行列式 the determinant, if we have some matrix multiply to each other, then the determinant of the product is the product of the determinant of every matrix. Okay. So this means that you can see that W0 have the determinant equal to 1, and R times R rho times R minus rho give us determinant equal to 1. So finally we get determinant equal to 1. Similarly, determinant W minus rho is also equal to 1. So finally we get determinant omega equal to 1. Okay. But what is the determinant of omega? Since we denote omega as A, B, C, D, A, B, C, D, or I can write this as A, B, C, D. This tells us that AD minus BC is equal to 1. Okay? So, use this relation, we can write BC as AD minus 1. Okay? So, let me show you that if I calculate the square of omega, we get A, B, C, D times A, B, C, D, which is equal to A squared plus BC, B times A plus D, C times A plus D, and D squared plus BC. Okay. However, BC is equal to AD minus 1. So we can write this as A squared plus AD means A times A plus D minus 1. D squared plus BC means D squared plus AD minus 1. So it is equal to D times A plus D minus 1. Okay? And this gives us B times A plus D. And this gives us C times A plus D. So A plus D appears at every matrix element. Okay. So this means that omega squared is equal to A plus D times omega minus union matrix. Okay. A plus D times ABCD gives us this 4. Then minus the union matrix gives us this minus 1. Okay. So before we proceed further, we know that determinant omega equal to 1 implies that the two eigenvalues of omega, the product of the two eigenvalues is equal to 1. This is because we can diagonalize omega to get its eigenvalues, and this, according to linear algebra, suppose we have the first eigenvector and the first eigenvalue like this, and we have second eigenvector and the second eigenvalue like this. Then if I define lambda as the diagonal matrix, okay, then and denote this as the S matrix. Here V1, V2 are both column vector. Okay. So we can write this as omega S equal to S lambda. Okay. So this means that omega is equal to S lambda S inverse. So if you calculate the determinant of omega, you see that since S inverse is the determinant of S times S inverse is equal to 1, so the determinant omega is equal to determinant of lambda, which means that lambda 1 times lambda 2. So since these two eigenvalues multiply to each other equal to 1, we can denote lambda 1 as exponential I theta and the lambda 2 as exponential minus I theta. Both of them have the exponential form. Okay, so the multiplication of this gives us 1. You may wonder why I use I factor here. Okay, this is because this I factor will give us the eigenvalue equal to a phase, and a pair of wave plates, its function is just change the phase of the polarization. So it is very reasonable to denote the eigenvalue as a phase factor. Okay. So what is A plus D? The A plus D is in fact the trace of omega. Trace 好，就矩阵里面呢有两个很关键的量是在所谓相似变换之下不变的，一个是行列式，就是刚刚说的行列，你可以做这个转换，行列式不变。另外一个不变的呢是所谓的 trace 就是把对角线的圆珠加起来。好，那你也可以数学上可以证明这 trace 呢就是等于两个 eigenvalue 相加。Okay. Mathematically, the original matrix and its diagonalization are related by this similarity transformation. And the similarity transformation does not change the determinant, and also it does not change the trace of the matrix. Okay, the trace is the sum of the diagonal elements. And since we denote lambda 1 as exponential I theta and lambda 2 equal to exponential minus I theta, so the sum of these two terms give us 2 cosine theta. This gives us A plus D is equal to 2 cosine theta. So this means that we can define cosine theta as the mean value of A and D. Okay, so we use this result to get this 2 cosine theta times omega minus I. Okay. And we can multiply the result by sine theta and divide them by sine theta. So we have this sine theta. And the 2 sine theta cosine theta is equal to sine 2 theta. Okay, minus sine theta. This is the square of omega matrix. Okay. So now I want to find the general rule of the high power of omega matrix. Let me try omega cube. This is equal to omega squared times omega. So I multiply the result by omega squared sine 2 theta minus omega sine theta over sine theta. And omega squared is equal to this quantity. So we have 2 cosine theta omega minus unit matrix times sine 2 theta minus omega sine theta over sine theta. And the result is 2 sine 2 theta cosine theta minus sine theta times omega minus I sine 2 theta over sine theta. Okay. You may not recognize what is the first factor. What is this factor? This seems very ugly, but we can try to write it in different way. Suppose I write this as this plus cosine 2 theta sine theta plus sine 2 theta cosine theta minus cosine 2 theta sine theta and minus sine theta. Okay? These two terms cancel each other, and the sum of them give us this 2 sine 2 theta cosine theta. However, the first one, this one, give us sine 3 theta. And the second one give us sine theta and minus sine theta. So finally we get sine 3 theta. Okay? So this means that we have this omega sine 3 theta minus I sine theta 2 theta over sine theta. Okay. So you see that for omega squared, here we have a 2, here we have 2, this have 1. For omega cube, here we have 3, and this factor 2. So you can guess that it is very easy to guess that in general, in general, we have the m power of omega equal to omega times sine m theta minus I times sine m minus 1 theta over sine theta. Okay, you can prove the result for general m by so-called 数学归纳法 mathematical induction. Okay. Or you can try different way to prove the result. So finally, we get this representation. This result is called Chebyshev identity. Okay. 叫柴比雪夫恒等式。好，柴比雪夫恒等式。好 In the textbook, the theta is denoted as k lambda. Okay, in the textbook. To understand why the author denote this as k lambda, you had better read chapter 6. Then in chapter 6, you will find the reason why this theta is denoted as k lambda. Okay, so now we have this theta defined as 1/2 of the sum a plus d. So we have cosine theta defined as 1/2 a plus d, and we can use this parametrization to find the f power of matrix omega, which is what we want to see. Okay, this is the so-called Chebyshev's identity. Okay. So once we know how to calculate the result, then finally we see that we want to calculate the final polarization of the state. Suppose originally we have a polarized light along the polarization. The original polarization state of the light is given by the Jones matrix Ex, Ey. After the first polarizer just use the px to time this polarization state. Then it encounter this matrix M, and matrix M means the M unit cells of the wave place, and then finally it encounter the Y polarizer. So this means that Y polarizer is 0, 0, 1. M, I denote M as M1, 1, M1, 2, M2, 1, M2, 2. And the X polarizer is 1, 0, 0, 0 times EX, EY. Okay? So finally, we get non-zero EY prime and 0 EX prime. EY prime is equal to M21 times EX. Okay. So what is the transmission? Transmission coefficient T is equal to the absolute square of M21 elements. But M21 is just C times sine M theta over sine theta. Okay. And what is C? C is minus B. So this gives us sine or rho sine squared half gamma times sine M theta over sine theta squared. So now we see what happens if we consider rho equal to pi over 4n and gamma equal to pi. We see that first we want to know cosine theta now is given by 1/2 A plus D. You can check the form of A and D. You see that since D is A plus, D is A star. So this is in fact the real part of A. So you find the real part of A to find the cosine theta. Let me try to find the real part of A. We have cosine theta equal to the real part of A contains cosine square half gamma minus cosine square 2 rho sine square half gamma plus sine square 2 rho sine square half gamma. Okay, and here I can write this as 1 minus sine square half gamma. Okay. Yeah. Minus cosine square 2 rho sine square half gamma plus sine square 2 rho sine square half gamma. Okay. So我从哪里算错？这边的话 ，OK， 好，这边一减它的话又变成 cosine， 所以这边就变2倍。So 1 minus 2 cosine squared 2 rho sine squared half gamma. Okay, this is the cosine theta. So if we take gamma equal to pi, half gamma give us sine equal to 1. This gives us 1. So if I try to make a transformation, I define theta equal to pi minus 2 pi. Then cosine theta becomes cosine pi minus 2 pi. Pi gives us minus sign. Cosine minus 2 pi. However, cosine is even function, so this is just equal to cosine 2 pi. So minus cosine 2 pi. But cosine 2 pi is equal to 2 cosine squared pi minus 1. So this gives us 1 minus 2 cosine squared pi. Okay? So if you compare this result with this result, then we get the result that cosine chi is equal to cosine 2 rho times sine half gamma. Okay? So once you choose gamma equal to pi, this indicates that chi is equal to 2 rho. So if you try to find, you substitute this result into this absolute value, you get 1. I will show you the result. 下一堂课。